Let's find where the tangent to our curve is horizontal. We have a cubic curve and need to find points where the tangent line is perfectly horizontal. First, let's understand what we're looking for. A tangent line is horizontal when its slope equals 0. This means the derivative must equal 0 at those points. Our curve is y equals x cubed minus 6x squared plus 9x plus 2. Let's find the derivative of our function. Taking the derivative, we get 3x squared minus 12x plus 9. We use the power rule, multiply by the exponent, and reduce the exponent by 1. Now we set the derivative equal to 0 to find critical points. We have 3x squared minus 12x plus 9 equals 0. Dividing everything by 3 gives us x squared minus 4x plus 3 equals 0. Let's solve this quadratic equation by factoring. Factoring gives us x minus 1 times x minus 3 equals 0. So x equals 1 or x equals 3. Now we need to find the y-coordinates by substituting back. Let's start with x equals 1. Substituting x equals 1 into our original equation. This gives us 1 minus 6 plus 9 plus 2, which equals 6. Now for x equals 3. Substituting x equals 3 into our original equation. This gives us 27 minus 54 plus 27 plus 2, which equals 2. Let's visualize these points on the curve. Here's our curve with the 2 points marked where the tangent is horizontal. Let's state our final answer clearly. The coordinates where the tangent is horizontal are the point 1, 6 and the point 3, 2. These points represent a local maximum at 1, 6 and a local minimum at 3, 2.